Swayam Prabha. Digital India. Educated India.
Good morning everybody, and let us discuss our topic on duplex bearing and the bearing mountings. And we have seen that there are different type of mounting configuration, O type, X type and the tandem bearing type, and we have seen the different advantages and disadvantages of each one of them. And we have also seen that because of the temperature rise, there is a thermal growth of the system, mostly it is a shaft, and how to take care of that particular thermal growth so that there should not be any type of problem during the operation or the after the operation. So, let us talk this thing further in this space. So, here what we have seen in the last class, that whenever there is a high temperature rise, then heat will be generated, and because of the heat generation there is a growth of the spindle shaft. So, we have to do something new, that is called the floating housing with a spring. So, what is means, that means let us see those things in detail. Right. So, now this is the same configuration here. Now, what we have to do here, that floating housing is mounted in a precision bore or a ball cage and is free to move in axial direction to the extent of clearance S. So, this is called the clearance S. Right. So, this is the clearance S. Now, this clearance is given to the rear end of the house. So, now this is the front end, this is actually opposite. So, our tool is located here and this is the rear end, and we are giving a small amount of clearance to that direction. That is because that we have to provide this additional space, so that whenever there is a thermal growth of the shaft, at that time this shaft will be accommodated within this particular dimension. So, you will not get any type of extra loading or compression or expansion of different components during the operation of the spindle. So, when the spindle grows, the rear bearing are free to move also. So, now this particular end part that we have seen in that cantilever example, that one end is fixed. So, now see this end is fixed because we are using a cutting tool here. So, if there is a expansion in cutting tool direction, then your Z axis will be compromised because your Z axis offset will be changed. So, we are not doing anything at that side. So, this whole bearing is completely firmly rigid. So, expansion will happen at the rear end only. So, your rear bearing are free to move. So, whatever this S is, that much amount of space you have where your rear end will be moving in the direction. Right. So, in this way the preload seen by the bearing does not change and it is maintained by the force exerted by the spring. So, we are using spring preloading also here, and we are providing that gap also. So, whenever there is a expansion, at that time your spring will be further loaded, and then it will be compensated by that, and once the temperature comes down to the required level, again spring will this whole shaft will again contract, but you have a spring loaded here. So, spring again actually get released, and then it will maintain to the original position, but it should be within this particular S value, it will be few micron only. So, that much variation can be acceptable for this particular type of settings. Right. So, it is used for high speed milling spindle and the grinding spindle, because here what we are looking, that we do not want to disturb the system because of the heat, because heat is one of the things which we have to maintain or we have to regulate in such a way that there is no any type of thermal deformation of the component or tool or any type of geometric orthogonalities. Now, coming to the hybrid ceramic bearings. Now, till now what we are discussing, that we are discussing about the ball bearings where these races are made of steel and ball is also made of the steel in case of ball bearing. Right. But now we are talking about hybrid ceramic bearings. Why we are talking hybrid ceramic? Because we are using ball of a ceramic material. ceramic material ball, and then rest is steel, we are using a steel, right. So, that is why it is called hybrid ceramic bearings. Right. So, ceramic silicon nitride, not only silicon nitride, now there are many also there, let me name those things also. So, silicon nitride is there, then silicon carbide is there, then aluminum oxide is there, zirconia oxide is one also there. So, these are the different type of ceramic materials which are mostly used for fabrication of these precision balls. Right. So, ceramic balls have 60%, ceramic balls are 60% lighter than the steel balls, are 60% lighter than the steel balls. So, why this is important? Because now we know that if lighter the things, you can actually increase the speed beyond a certain limit. Now, for the high rotational speed, centrifugal force pushes the ball to the outer race and even begin to deform the shape of the ball, because now we know that centrifugal force Fc, we can write that m omega square r, correct. So, this is the radius, this is the speed, and this is the mass, correct. So, we are not actually doing anything with the radius, now size is the same. So, wherever this is the thing from here to here, this r is not changing it. We are not changing the speed also. So, speed is also same, omega whatever we are rotational speed is there, but we are changing mass, right. So, now it is a 60% less weight. So, now if you see this particular thing, now if you use a centrifugal force with the steel ball, now what is going to happen? That now you have a ball here, and then when you are rotating at the time, it will go in this direction, right. So, what is happening, that centrifugal force pushes the ball onto the outer race. So, you have a this particular ball, and then this ball will be moved toward this particular part because of the centrifugal force. So, you have outer race, and this is the ball, and this ball is striking in this direction, that means it is continuously pushing in this direction. So, you will get additional force on the top part of the inner face of the outer race, and because of that, what is happening, you will get the deformation of the ball. So, which one is actually creating problems? So, sometimes it will deform the ball also, sometimes it will deform the outer race also. So, in that is the reason for the particular ball bearing. So, when you are using ball bearing, at that time it will create a problem with the outer shape of the ball or the surface profile of the outer race. So, because of that, you are not able to go beyond a certain limit of the speed, but now we know that we have 60% less weight. So, now you can go further, because now centrifugal force will not play important that much, because your aim is much small now, correct. Right. So, this deformation leads to the rapid wear and bearing deterioration, because that is in case of the steel ball, when you are using a normal ball bearing, where everything is made of steel. So, ceramic balls will not be affected as much at that particular same speed. So, now you know that now you can expand the area, that means expand that particular speed. Earlier it was a limited, or range was fixed, but now you can expand that particular range to a certain higher level without creating any problem. So, by using a ceramic ball only, actually you can go up to 60% higher speed for a given ball bearing size without sacrificing any bearing life. So, what does it mean? That do not, without changing anything, just by replacing the steel ball, ceramic ball by steel ball by the ceramic balls, you can actually increase the speed with a 30% high without changing anything. You keep the application everything same, and then you will also still get the same bearing life, but increasing the speed. So, that is the very good advantage, because we know that in micro machining our speed requirement is very high, and this is one of the best way to get this thing done without changing so many other things, right. And this is one of the thing, because now you can see here at this particular part that we have just changed the balls only, correct, but still we are using the ceramic. So, that is why it is called the hybrid ceramic bearing, but bearings are available that are the fully ceramic bearings. So, these are called the full ceramic or complete right. So, if you see here the race, outer race, inner race, everything is made of ceramic. Now, if you consider this particular thing, then this particular whatever advantages you are getting for hybrid bearing, that will be even higher in this particular case, correct. So, these are the full bearings and they have very specific application for the mostly the high precision components, because the cost is also very high for this particular complete ceramic ball bearing or the hybrid bearing compared to the normal bearing what we are getting in the market. So, cost is the one issue where we have to actually do one type of optimized study, that which one is better, that by putting more cost what you are getting in terms of the spending money. So, cost versus amount of things which you are getting, that is more important in this particular case, but there are lot of advantages associated with this ceramic bearing. Let us see those things one by one. So, one thing is that they are lighter. And second thing is that ceramic balls do not react with the steel race, because these are the ceramic material and mostly they are inert with the other acidic environment or some other things. So, that is the big advantage here, because when you are using a normal ball bearing, what was the problem, that one of the most prominent mechanism of bearing failure is the surface we are created by the microscopic cold welding. So, what is this cold welding, that when you have a ball bearing, normal ball bearing, what is going to happen, that when you rotate at extremely high RPM, what is going to happen, that these are the contacts, right. So, these are the contacts, that is mostly the point contact, but there are many point contacts depending on the how many balls are located in that particular material, particular bearing. So, when you are rotating at extremely high RPM, what is going to, because there is a heat generation, right. Because of this heat generation, what is going to happen, that it is cold weld with the inner race and outer. Cold weld means it is not like a permanent welding or something, that, but it is a temporary attachment with the ball and inert race. So, it is a temporarily attachment of ball with races. Right. So, it will temporarily attach because of this extremely high speed and the high heat generation, and that is creating problem, that it will actually give a some type of removal of those parts. So, when in this condition, what is going to happen, if you continue this operation, this weld will be broken at the later stage when you are operating, and when the bearing rotates, this weld will be removed from that and creating the surface roughness, which leads to the heat generation in the bearing failure, right. So, when you have a contact here, so this is the contact part, and then you further move in this direction, then what is going to happen, that it will actually rotate. When it will rotate, so this particular cold weld, it will either remove material from the on the race, or it will remove material from the ball. So, in both the cases, the roughness will be increased, and because of that it will further, because now your surface is something like this, if it is removed from this particular part, or if it is removed from the ball, then it will be something like this. So, now ball is not in the same shape, and in this particular case ball will have some additional material attached with this particular part, correct. So, in both the cases, this is what is the problem, but it will happen at a microscopically, but still it is enough to create a damage to the ball bearing, and finally all the thing will be failed at the later stage. Right. So, ceramic materials drastically reduce this mechanism, resulting in the longer bearing life, because ceramic is a different material and it has different properties compared to the metallic surface, because it is a ceramic part. So, it will not actually create this type of cold weld between the races and the ball. So, that is one of the advantages. Ceramic ball bearing operates at the lower temperature, because they are mostly near perfectly rounded, because it is something like a glass like surface. Whatever you are getting here, it is a glass like surface. So, it is surface is very shiny surface and looks almost a glass like. So, you will get a very tight tolerances in terms of the roundness and the surface roughness. so operates at a much lower temperature than the steel ball, because polishing of the steel ball is very difficult compared to the ceramic ball. So, dimensional accuracy is more controlled in the ceramic ball bearing, and because of that you may not get the temperature of zone in the higher case. So, it will operate at a much lower speed than the ball bearing. This results in a longer life of the bearing lubricant, because wherever you are using bearing lubricant, at the time if the temperature is very high, then bearing lubricant will change its property. Mostly it is a viscosity. Then higher temperature, then lower viscosity. Right. So, because of that, what is the mean, you are changing the property of the lubricant, and sometimes the lubricant becomes a very ineffective in the complete dissipation of the heat and the reducing the friction of this particular part. So, it will not create problem if you are using a ceramic ball instead of a steel ball. So, less friction generated in the bearing, which increases with increase in the heat. So, when you are further go down and means going high and high in terms of speed, it will generate the heat, but it will not create so much of friction in this particular, because now the systems are different, not is a steel bearing. Low thermal expansion as compared to the steel ball, because metallic ceramics have very low thermal coefficient of expansion compared to the steel. So, even if there is a high temperature, you will not get the thermal growth of the system. That means mostly the different components of the bearing. So, that is the also advantages, and they operate at a much lower vibration level, because spindle utilized hybrid ball bearing exhibits a very higher rigidity, because now they are very strong also in terms of the different type of mechanical properties, and they have higher natural frequencies. So, you can go beyond a certain limit of a speed, so that your natural frequencies it will not reach to the resonance of the particular system, and making them less sensitive to the vibration. Because if your system is not rigid, then what will happen, that after crossing a certain level of a speed, at that time it will start wobbling because of the internal creation of the clearances, and that is not happening in this particular case. Then some of the other advantages of the using ceramic balls, that it has a low thermal conductivity, because of that reduce the amount of heat absorbed within which reduces the cooling system requirement, because we will see in one animation that you have to cool the spindle also, either by means of a air or by a water jacket. So, in this particular case, if it is not accepting the or saving the heat within the body, at that time it will mostly relieve the release the heat into the atmosphere by different type of these cooling systems. Low deformation, because they are very strong in terms of stiffness, and useful for the machine that work under the extreme pressures, and high temperature hardness as compared to the steel, because it retains the strength and hardness up to the 1800 Fahrenheit. So, in this case Fahrenheit, in this particular case you can get the very high temperature operation without creating any problems. And some other property, the density is very low, because you can see that it is 60% lighter than the steel. So, that is what of the advantage here. Very high flexural strength, almost 1 GPa. So, that is when it is under the flexural loading, at that time it will not create any problem, and high fracture toughness 6 MPa per meter square. So, these are the some of the properties which are very suitable for accepting this particular ceramic or hybrid ceramic bearings for the micro machining operation. So, that is the reason that it is better to go with this type of ceramic bearings whenever you are using a spindle for the micro machining operation. So, now let us see that what are the complete complete assembly of the bearing. So, these are the two things, that what things we have to take care, during the design of this part. So, this is one of the companies who are making this type of high precision spindle, and this is the cross sectional view or the section view of this particular spindle. Now, you can see that there are a lot of bearings. So, these are the set of bearings, this is called front bearing and these are called the rear end bearing, right. So, liquid cooling of the bearing components and the motor. So, now if you see this blue color, so this is called the liquid water jacket, which is created within the system. So, now you can see that this particular thing is one liquid jacket is given to the bearing also, and other is the full components here, because this is an integrated or integral motor type spindle. So, everything is within the system, motor is also there, and then the transmission components are also within the part. Right. So, this is one of the system where what is going to happen, that when you cut the material, at that time we know the chip are forming and they are spreading in random direction. So, one of the ways that you should make sure that chips are not actually attached with the tool here, because we know that when you are working with a micro tool, at that time fluid space is also very small. So, if material is fixed, or what is called the loading of the tool, then the chip will stay onto the cutting tool here. So, if you are providing a coolant through this particular part, at that time you are actually focusing the coolant to the exact location where you are getting material removed. So, chip will not actually come into contact with the fluids or any other direction, and it will be spread away very quickly around the out of the machining area. So, coolant through the shaft and the spindle housing. So, this is one of the way. So, your spindle has also one of the ways by which you can provide the coolant. So, this coolant nozzle is such a way that it will focus to the location of the machining. So, this is the machining zone. So, this particular coolant which is coming from this particular spindle housing, it will directly focus to the cutting zone. One is that you have a through coolant shaft. So, shaft has also one of the passage through which you can supply the coolant. So, coolant are very concentrated around the machining zone, that is called the interface between the cutting tool and the workpiece. So, whenever you are doing machining, at that time heating will be completely escaped by the particular cooling element. So, heating will be most of the taken care by this cooling media, and other than the chip will be also spreaded away from the machining zone and the cutting tool. So, now coming to the this is called the tool retention mechanism or the tool holder mechanism, right. So, when you are putting this particular tool, and we have discussed some time ago, this is called the drawbar mechanism. So, this is a drawbar mechanism. So, how this will work, that when it is expanded, at that time you can push this particular cutting tool holder into it, right. So, it is going down, and then it is actually getting inserted inside it. So, this is called the automatic tool change and drawbar monitoring system. So, here it will tell you that you are actually measuring the forces and the contact forces. So, once everything is firmly contacted, then you will get the signal also, right. So, this is the automatic tool bar monitoring system. So, this is the rear end of the drawbar, where you are actually moving this particular bar to grip the tool. So, now you are releasing the system. Right. So, now it is gripped, and now you can remove this part. So, now it is released from this part. So, for attaching and relieving, you can do the same thing. Now, another thing, that once when you put it inside and when you relieve it, at that time whatever, sometimes some microchips or some foreign dirt particles, sometimes it will stick to the surface. So, if you do not clean this part, the next time when you are attaching another tool from here, it will not be fixed completely here, and because of that you will get the run out. So, that is called the periodic run out or the static run out. So, here some spindle has this type of additional mechanism by which once the spindle or the tool holder is released, after that you provide one type of taper cleaning of the tool interface by the air. You supply the air. So, air will actually get a positive pressure. So, it is pressure is very high here. So, when you are pushing the air here, so air will be coming out from this particular passage to the atmosphere. So, even if there are some dirt particles or some foreign element which will create some problem at the interface, it will be expelled away from this particular zone. So, that is the automatic tool cleaning of the tool interface by the air. Now, coming to the bearing lubrication. Now, there are different methods are available. So, this is one of them which is showing here. So, it is oil or the air lubrication of the front and the rear bearing. So, it is you provide one completely oil monitoring system here. So, it will provide the continuous oil supply to the bearing races here, and then it will drop by drop everything will be lubricated within the system. Now, you can see here the once the bearing is rotated, then you will get the lubrication of the balls as well as some other components continuously. Right. So, this is the sensor for measuring the axial shaft movement. So, now your shaft is in this direction. So, how much is the shaft move in this direction? That is mostly when we are talking about the drilling of a hole or doing a micro drilling or some other operation, where it will create some problem at the later stage. So, this is the sensor for measuring the axial shaft movement. So, it is mostly some type of capacitive type of sensor or the Hall effect sensor, which will actually monitor the how much is the axial displacement of the shaft. And every time it will give a signal to the system, so that you can maintain or you can monitor this particular signal. Right. So, this is the air purge, because whenever you are doing machining, you will get the very fine amount of particles because of the machining also, as well as some of the chip also. So, this air purge will make sure that none of these things will actually getting inside the system. So, we are continuously providing the this air purge, so that nothing is coming out inside the system, and system is completely secured from the coolant as well as the external element like a chip or dirt or some type of other microscopic elements. And this is the rotary encoder, which is used for measurement of the or the calculation of the rotational speed of the shaft. But here we are using rotary encoder because we want to measure the rotational only. That is the best way for doing this thing. And temperature sensors are also attached here, so that whatever there is a any type of axial movement or something, that will be compensated within the part. So, this is all about one system, and let us see this one more. So, this is also one other company, Fisher. Right. So, whenever you do machining or something, you always get some heat generated within the system. So, what you have to do to counteract those type of things. So, you will get some type of Z displacement because of the heat. Right. So, what are the solution for that? And so, this is again the cross section of the whole system. So, now this is the cooling channel. Now, see, several channel cools the shaft, temperature changes and the axial growth are almost eliminated. So, these are the shaft cooling system, because we know that we have seen that the thermal growth is mostly happen to the shaft. So, if you want to avoid the thermal growth, what you have to do, that you have to cool the shaft during the operation, so that you will not get into type of thermal expansion. Right. And this is for the bearing and the motor. So, again you are getting the same water jet cooling or the air cooling, by means of that you can maintain the temperature within the system. Right. And then optimized air or oil lubrication guarantees the minimum losses, maximum speed and availability and reliability. So, you can maintain this thing, your system you can operate continuously without any problem. So, this is the greasing unit. So, you continuously provide the greasing also to the bearing and different other components. So, it can reduce the friction, and this is the sealing of the spindle. So, this is one of the way through which through the tool actually you can provide. So, this is the different kind of fluid for the internal tool cooled to a maximum speed. So, even without actually restricting the speed of this spindle, you can provide cooling lubricant through this particular spindle. So, this is the cooling lubricant, You can go with the minimum quantity lubrication also, where you can actually give a very minute amount of supply of the coolant, so that you can do some type of cost cutting in that. And another one is the you can supply air also. So, these are the different ways you can actually control the system. So, now we have seen different components of bearing and the installation of the bearing within the system also, and this particular whole system will tell you that how the bearings and all the things are actually assembled within the system of the spindle, and how things you have to take care during the operation. So, let me stop at this location. We will continue our discussion on this spindle component or the machine tool component in the next class. Thank you very much.